Convert 190 from degrees into radians. Who remembers the formula to do that? Degrees into radians.
Pi over 180.
Multiply by pi over 180. Yeah. Okay, so let's, if you've got your calculator there, yeah.
It's 19 over 18 pi.
So yeah, it looks like this now. It's 190 multiplied by pi over 180. What did you get there?
19 over 18 pi.
Yeah, now what is that as a, what is that as a decimal?
Some 3.316.
3.316, so 3.32 radians. Okay. The B part now? Yes? Okay, so B part. I'll draw the picture again here. So what's happening? This here is 90. This here is 90. This here is 45. What's this angle?
45.
Why is that?
So it's 180.
Yeah, has to add up to 180. This here, what's this angle?
90.
No, this one.
No, 45.
45 because
Supposing.
because they're opposite each other. Yeah, this is 90, and so what's this one here? This one's also 45. So all the angles here are 45. Now, some distances you know. So you know that this is 60. Now this question is interesting because you don't need to use fancy pants trigonometry. If you just think for a moment. If this is 60, this is 45 and this is 45. When a triangle has two angles the same, what is this triangle called? Yes, isosceles triangle. And do you know what that means about their sides, Josie? The two are the same. So if this is 60, then this one here is 60. Because as you pointed out, if you have an isosceles triangle with these two angles the same, then these two sides are the same. Now, how far was it from here to here? 80. So this must be 20. Oh,
Yeah.
back it up there, Mr. Stephen. So if here to here is 60, and the total is 80, then this must be 20,
How do you know that?
because the total is 80.
Yeah, okay. How do you know it's 20?
Because 60 plus 20 is 80.
How all of that?
Oh,
80.
okay.
Look at Stephen Hawkins. There's a new kid in town. All right. We're good. Yes. Yes, we're good. Okay, we're good. Right. Now the next part. That's not quite finished. Does anybody have any ideas on how I could find this side here? We're looking for, in the question they want to find this side. I'll call it X here.
So, central.
Alright. Wait. True. But I think we can do this whole question without using a sine, a cos, or a tan.
If this one is 20, so that one will be 20 divided.
Nope.
Huh?
Stop right there.
No, root 2 something. Root 2.
No. Oh, you found it. Great. Any ideas? Anybody? No?
What about this side?
Yeah, what about it?
Supposed to come from X.
Yeah, what about it?
We have it?
We don't, kind of.
We don't.
This side here.
Okay, so we can get it.
It is rule, the root 2, I think.
Yeah, but dudes. Isosceles triangle. Is that an isosceles triangle? On the right. Yeah. So if this side is X, how much is this side?
X.
X. And who's our favorite Greek mathematician?
You.
sorry, I'm not actually Greek. Sorry, who's our favourite ancient Greek mathematician? Again, not ancient or Greek. Perhaps Pythagoras? Just as an idea. So you can use Pythagoras here. X squared plus x squared equals 20 squared, because this is a right angle triangle as well. So you get x squared is 20, well, it's 2x squared is 20 squared. So then x would be square root of 400 divided by 2. So yeah, the x, our answer x is square root 200, which is 141.1? 14.14 kilometers.
Here I cannot use sine and cosine.
No, you can. I'm making a point. You didn't need to. You could have done it with more basic maths even.
Yeah, but Stephen,
What?
it's right, if I only
I
divide
know, but I'm trying to get you to think. Expand the way you look at problems.
should be right in that.
Yes, but I'm trying to expand your mind. Okay?
to make our life difficult.
No, this is better for you. If you, it's good to think about problems in different ways. It's healthy. It's normal.
To think.
You need to reserve some time for thinking.
Yes, to do everything fresh.
All right. Now the next part. Yes, the next part's interesting. We do need trigonometry for the next part. So for the next part here, this is part 1, and now part 2. The boat. There's a boat actually here, and the boat doesn't want to go to Y. It wants to head across to this point here. So it will need to increase its angle.
Yeah.
It will be more than 45. Can you see that? Yeah. Now how big is this side? 60. And how big is this side?
60.
No, from all the way here is 80. And we would like this angle here. So what could I use to get the angle? Not Pythagoras. Pythagoras doesn't give angles. I could just simply say, if I call this angle here theta, tan theta equals 80 over 60. Because you have a big right angle triangle here, don't you?
So which angle are we trying to find?
Well, we're trying to find this, the ship needs to increase its angle to land at L instead. So here what's happening, Josie, is it's heading off this way now.
Yeah, okay.
So we're trying to find this bigger angle here.
Alright.
Okay, so theta,
Don't need to get the distance of the side.
no, we have everything. Tan inverse 4 over 3. What's that, please? You're in radian mode, aren't you?
Sorry.
You're in radian mode, aren't you?
Yes, wait.
Please do it in degrees, because we're dealing with degrees here. Dude, what is it? 53.6 or something?
53.13.
53.13 degrees. So the answer is, now remember previously the angle was 45, so the answer is increase its angle by 8.13 degrees, because that's how much the extra piece is here. This is 8.13 degrees extra.
So you add it.
Yeah, 53 minus 45, yeah. Okay, part C. Can I do part C? So part C is they give you a triangle. This side is 65, this side is 68, this side is 7, and I want this angle here, theta. What rule can give me this angle? Correct, cosine rule. So I have 7 squared equals 65 squared plus 68 squared minus twice 65, 68 cos theta. So, what's wrong?
Which angle?
This one here. It says the angle opposite the smallest side. Or, what, sorry, the smallest angle. That's this one here. 7 squared minus 65 squared minus 68 squared divided by minus 2, 65, 68 equals cos theta. For what? The left?
The left, yes.
0.99.
Yes.
Are you sure?
Yeah.
Don't believe you. It's crazy. Crazy talk. Let me see. I mean, it might be right. Divided by?
5.45.
Come on.
5.45. 5.45.
No.
0.99.
I got 0.99 here.
Trust me, okay? Trust me.
0.9954.
No. Yeah, okay. I just wanted the part on the left first. You already did the cos inverse.
Yeah.
Yeah. So before you do the cos inverse, you get 0.995.
Yeah, but I did that.
Yeah, but don't skip too many steps in the exam. Okay?
Yeah.
So in the exam, you would want to do it like this. You would want to say, this is 220 over 221 cos theta. So theta is cos inverse 220 over 221. So theta is
5.45.
cos inverse 220 over 221. 5, yes, 0.45 degrees.
Very ingenious in the design.
You leave him alone now, don't pick on him. Sketch. No like. No good, huh?
Sketch.
Yeah.
Engineers like sketch.
Do you? Yeah. So far, hey, have your answers been right so far? Yeah. Tell me, did you use for the B part here? We were able to do it without using sine or cos. Did you use sine or cos? Use sine rule, yeah. And you got the same answer. Yeah. Okay. D part. Sketch. Okay. Y equals 2 sine 2x plus pi over 4 minus 1, and x is between 0 and 2 pi. What's that, Carrara? What?
No, I'm just asking what question.
What?
Asking a question.
What question? Is that, have you got a cigarette? I so need one right now.
I'm gonna die.
Alright. Okay. So the way I do this in class is by using a table. I don't know which way you've seen it, but you can see the way I do it in class. So first we start off with a table. Actually, sorry, before I've drawn the table, let me just clean this answer up a little bit. I write it as y equals 2 sine 2 bracket x plus pi over 8. So I've just changed the inside a little bit here. I took the 2 out. In fact, this is the normal way you should write these. And the reason for doing that is we normally call this A, this B, this C, and this D here. Now I can make my table. Start and min max. Okay, so actually we start with sign firstly. So if we have, well, I'll wait till you're ready. Have you seen it this way before? No. Oh, exciting. What's he gonna do? Which way do you normally go about doing these?
Sketching, John just said they're going to review either A or B, or C or D. It's going to be 2 values, not 4 values.
You have inside information. I'll pretend you don't know this and show you what to do if you have A, B, C, and D. Yes? No, don't get too excited now. Okay, so firstly, sine. So sine starts at 0, ends at 2 pi. Its smallest value is -1, and its biggest value is 1. So, you know, sine goes from 0 to 360. Its lowest point is -1, and its highest point is 1. So far, it makes sense? Okay, now this A here, what is the effect of this A? What does it do to the graph? It stretches the graph vertically. So instead of being 1, it'll now be -2 and 2. But does it change anything horizontally? No. Done. Okay. Now what is the effect of the B here? It contracts horizontally. So instead of going from 0 to 2 pi, it's now going to 0 to pi. Contracts. Yeah. But does the height change? No. Alright, do you remember what the effect of the C here is?
It's moving up and down. I know.
Up, down, up, down, down, left, right, A, B, start. No? No, me cheat code? No? Left, which is left or right?
Yeah, it's left.
Correct. How much left?
8
Pi over 8. So it moves, yeah?
How do you know it's left?
It's a bit weird, but because it's a plus, it goes to the left.
Yeah, okay.
And if it was a minus, actually, it goes to the right.
Yeah.
So this goes to the left to minus pi over 8. The 0 gets shifted to minus pi over 8. And instead of having pi, we'd have 7 over 8 pi. Minus 2 to 2. And finally, the -1 here. -1? Which? It'd be down. So this is still minus pi over 8. This is 7 over 8 pi. This will be -3. And this here will be 1.
Tell me why it's 7 over 8.
Pi minus pi over 8 is 7 over 8 pi. Move it to the left.
This is the final answer we have.
This is what we can use to make the graph now. How are we doing for time? Oh great, we'll finish with this one. So can I go down?
Yeah.
Yeah. So if I look at my graph, in the question I said I want you to go to 2 pi, so we need to be smart about how we break it up. So look, because I'm dealing with pi over 8, I should break my pi's up into 8s. So for example, here's pi over 4, pi over 4, pi over 2, 2, 2, and then split them all up again. So I know it's a bit hard to see, but that's pi. That one there is pi over 2. That one there is 3 pi over 2. And it's hard to see, but each of these is pi over 8. Each of these units is pi over 8. So what you do, you want to start at need x and a y, of course. You want to start at minus pi over 8. So that's minus pi over 8 there. So in the exam, with a pencil, draw a very light line going down at minus pi over 8. And then finish at 7 over 8 pi, which would be here. Oh yeah, sorry, I also need a 1, 2, 3. 1, 2, 3. Okay. Start at minus 3, so that's here. So again, with a pencil, go across. And then at 1, go across. Okay. Now, for sine, does it start at the top, the middle, or the bottom? So when you picture your sine graph, where do I start? Do I start at the top? Do I start at the middle, or do I start at the bottom? Where does it start? Does anyone remember? It starts at the middle. So this box you've just made, can you see it here, this square box here? You break that up into 4 parts. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 1, 2, 3, 4. So that's one line going down here. And then 1, 2, 3, 4. So one line going across there. So you see I've split this up into 4 parts. And 1, 2, 3, 4, 5, 6, 7, 8. And then we copy the box beside it as well. So we'll copy the box over. 1, 2, 3, 4. Look, this is going to be the most beautiful graph you've ever seen in your life. Okay, so now that I've made these boxes using the numbers above, I can put in my graph. So you have top, middle, or bottom. Where do we start? For sine, we start at the middle. And where do we finish? At the middle. So the sine goes up, down, and back up. So I need to hit this point, this point, this point. Need to hit this point, this point, this point, and this point. So I get up. It's a work of art.
So this one is minus 3. Okay, 1 and minus 3.
Yeah, then here is minus 3. Now, let's see if this matches up. Y equals 2 sine 2x plus pi over 4. Yeah, why isn't my pi showing up? Oh, sorry, here's pi. Alright, let's try this again. Now if you compare it, I've got all the same points. So my graph is mostly under the x-axis, and it goes up, down, up, which you can see. Oh yeah, that's it. So I go up, down, up. I have too much to the left here on the program. I just actually need this part here for the question. But you can see it's the same.
This,
Yeah.
this point on the left, it is minus pi over 8.
This one here? Yeah.
Yeah.
Stephen,
Yes.
I have an idea. You can consider it in the exam.
Yes.
You give us the graph and you give you the table.
No.
And that way we will save our time and you are not going to see horrible graphs, disgusting
No. I will see beautiful graphs. I believe in you.
Come on, let's
Do we get graph?